Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're going to see problem number of atoms. Spoiler alert, we will see all the variations from basic. And again, this is not an actual logical problem. This is more of implementation based problem. So I'll highly recommend go and try the problem by yourself after understanding the logic. Cool. Let's start off. It simply says, again, it is kind of a chemistry problem. I know your chemistry is not that good, but nor in real life and nor in PCM. But yeah, it simply says that given a string formula representing a chemical formula, return the count of each atom. I'll just summarize the points for you. It simply says that actual atomic element always starts with the uppercase letter. As you can see, if I take the examples, H2O, MgOH. So K4ONSO3. So actual formula, as you can see, Mg. So this is one formula. Again, it could also say MgSuLARY. So this also can be actually your atomic element, which means starting with a capital letter and then some lowercase letters. Okay. Then zero or more lowercase letters, as you can see, zero or more lowercase letters representing the name. It is a name of that specific atomic element. One or more digits representing that element's count may follow if the count is greater than 1. If the count is 1, no digits follow. So after this, there can be a count. It can be 24, it can be 245, it can be anything. Now this represents for that specific element what is the count. If it is nothing, as you can see, if it is nothing, then it is a 1. Make sure if it's nothing, then it's a 1. Next cases, as you can see, they have represented that also, that H2 and O, it is 1. If O after that it is not there, it is 1. H2O2. Okay, after O it is 2. So for O it is 2. Now two formulas are concatenated together to produce another formula. I could have two formulas, as you can see, this formula and this formula. I can concatenate them, just a simple string concatenation to achieve a new formula. Lastly, a formula placed in parentheses and a count optionally added is also a formula, which means I can just have another formula. I can place them between parentheses. That also is a formula. After that parentheses, if I add some specific count, it can be 3, it can be 24, it can be 99, it can be anything. It can be 69 also. So then it will say that this 3 should be multiplied, which means it is saying H2O2. If I say 3 times, so technically it means H6O6, which means 2 into 3, O into O of 2 into 3. Just simple multiplication, how we open a bracket. Now, you have to return the answer in which you have to tell for every of these elements, here it is H, here it is Mg, what is the frequency of that specific after evaluating this entire string expression. So I will evaluate this entire expression. I will achieve Mg is occurring once, O is occurring twice, H is occurring twice. Return that as a string in a sorted format of element. So I can keep all of them in a map, or you can say in a string, in a vector of strings, and I have to sort on the basis of my element itself. Again, this is a requirement of the problem that you have to return the sorted order. It might or might not be a requirement of the problem. So you don't have to consider the complexity in the end part just to represent your answer. You are doing the sorting, so that is a different game altogether, right? Okay, so ultimately you will see that H comes first, then Mg, then M comes next, and then O comes next. So H is occurring twice, Mg is occurring once, but after Mg I will not add a 1. 1 is kind of, if it is there, okay. If it is not, then okay, it is represented as a 1. So if the frequency is 1, I should not put it here, and then O is occurring twice. So you must have realized that it's a simple approach in which for everything inside the bracket, I have to bring that frequency inside. Here in this case, the frequency is 2. So let's evaluate this example in which rather than N, let's keep a Mg. And rather than S, let's keep a S. My chemistry is weak, but yeah, SU, let's say. Cool. So as to just elaborate like what's happening. So okay, it is now K4, then O, Mg, then my SU, then let's say again, let's take OZY, then 3, then a 2, and then another bracket, and then a 2 finally. So now you have to evaluate this specific stuff. Cool. Evaluate this specific stuff. Very basic thing, that your prime aim is to get, again मकसद नहीं बोलना, your prime aim is to get the actual frequency of all the elements, but the first task is get the element out. Element, again, an element has a identification that it will start with a capital letter, then it will follow some lowercase letters, then for that specific, again, let's say capital, let's say uppercase. So uppercase letter, which will be just one, having a count of one, exactly one. Then some lowercase letters, it can be any number. Then some digits, which can be again any number. So this will technically say, in this case, my k, I have no lowercase letters, and then the count is 4. So far I can say the k is occurring 4 times. Okay. Then comes next. You will again evaluate the same thing. Oh, there is nothing lowercase letters, and the count, if there's no digits, so the count will be 1. Okay. So O is occurring once. Then again mg is there. Again m capital letter, g a small letter, count is nothing, so count will be 1. But you see that there was an open bracket also. What does that open bracket mean to you? Open bracket simply represents that there will be a corresponding closing bracket, and after that closing bracket I will have some number of digits. That digits will actually impact the count. Here, as you can see, O should technically in future become a O2. But right now I cannot do anything because I am iterating from left to right. Okay. Then let's say you got another element. So S will be there, and then a U will be there, which means a small element, and then the count will be 1. Okay. Then you achieve the next capital element, which is the uppercase element O. Then you go on to all the lowercase elements. Then you get all the digits. Then you get the specific count for this specific element. Now you achieve the closing bracket. After the closing bracket, I may or may not have any number of digits. So after this closing bracket, I should get how many digits are there, because it could have been a 23 also. So after closing bracket, I will count what all digits are there. Then up till the previous opening bracket, I should multiply that count with all of these digits or all of these numbers. But for that, I should know that where is its corresponding opening bracket. So for a closing bracket, you are trying to find the opening bracket. How you can do it efficiently? Stack. So what I could have done is, while I was placing all these elements, I could have placed them on the stack. So I could have taken and I would have said, okay, K, again, I will take a pair. My stack will contain a pair. Pair will say element and its corresponding number. Right? Same way, I will have an opening bracket because of this thing, and then my O will come, and then the count, which is the count will come, as in what is the count of that. Then mg will come, then the count will come. Again, an opening bracket came, then a SU will come, and then the count will come. Then the OZY will come, and then the count will come. Now you achieved a closing bracket. So after the closing bracket, you will iterate until you find the digits. You will concatenate all the digits. You will make a number out of it, and then you will keep on multiplying that number 23 to all of these until you find the opening bracket. Same way as we have discussed in the previous problems also. So let's imagine that you have only 2 here in this example. So you will go and multiply and make it a 6. Again, how you will do it? You will simply have to pop out, because it's a stack. It is one way. You could have taken a vector also. It would have been much more easier, but stack feels more relatable in this case. But vector could have made it much more easier, because here in this case you have OZY and a frequency of 3. So you have to remove this OZY from the stack just so that you can go deep, right? So OZY, now the new frequency of OZY should be 2 multiplied by the existing frequency, which is 3. So it became a 6. Then you iterated and then said that it should be SU with a frequency, earlier it was 1, it should now multiply by 2, so it will become a 2. You achieved the opening bracket. Okay, now you should stop. But you have made your stack empty. these elements could, maybe future, could actually end up being inside something else, because you can see that these was multiplied by 2, but another 2 is coming in. So firstly, you just did anything, okay, you just put them out, put them back in. So I will put them back in again. It was a vector, so I pushed OZY first and then I pushed SU first. But if I want to maintain the order, again, that is not important for us, but still, if I want to maintain the order, I can just push it back in the order itself from the back. Again, why I'm showing this, because I've done the same thing in the code also. So I'll push this back in my code. So I'll just push a SU with a frequency of 2 and then remove it. Then go on to this OZ, then push OZY with a frequency of 6. Okay. Then as you can see that this specific digit was done, I go on to next digit. Again, it's a closing bracket, so I should go and iterate until I find digits. I should get concatenate all those digits, make a number out of it, and then keep on multiplying until I receive my opening bracket. So I'll multiply again. I'll just do quickly. I'll multiply by 2. I'll multiply by 2. I'll multiply by 2. I'll multiply by 2. And then this bracket is gone. Now, this is the specific state finally, because ultimately after this, you will end. And this is your final state itself. And simply get all these outs. These again, these strings are your elements. And this is the corresponding number for them. Simply, you have to just tell that for these strings, what is the corresponding digits, convert these digits back to string, and make sure to either take a map. You can easily take a map, or you can actually, like take anything just to sort these strings out. So you can just simply sort these strings out with the corresponding numbers, or I should say frequencies, whatsoever you want to consider it as. Then I can simply represent as my answer. So because of the final stage of sorting, it will take n log n time, because I could have n possible, I can say k possible elements, when all the possible elements are 1 1 1 1 1, which means if I would have a k and then k like this, so okay, I can have n elements. So for the final sorting, it will take n log n time. But the task is, before this, whatsoever you performed here, how much time would that have taken? That's a question. Pause right now and tell. So it will take O of n squared time. Why is that the case? Because for any of these specific, as you can remember also, for this inner loop, you just went inside the stack, you multiplied everything, then you put all these back to the stack. If I just give you a quick glance, so this is what happened: A, B, C, D, E, and then you had a number. Let's represent the number. Okay, let's put the number only. What happened was, in the stack you put A, then you put B, C, then you put a, let's say you put a bracket here, and then you put a bracket here, and then you put a D, E. So when a number came in, you removed all of them, multiplied with a number D into 2, E into 2. Sorry, it should be D into 2, E into 2, and then you put them back. So basically you pop them out, multiplied it, put them back. So this is gone. Next time again happened the same thing. Remove them out, multiplied by 2, put them back, multiply by 2, multiply by 2, multiply by 2, multiply by 2, and then this is gone. So technically what could have happened is that I could have this kind of brackets in which I had, let's say, A 2, B 2, C 2, D 2. So what would happen in this scenario is, let's see, here it is E. So E will go, okay, then D, then C, then B, then A. As soon as the bracket comes in, okay, it has to get 2 out, get A out and multiply by 2. Then get AB out, multiply by 2. Then get ABC out, multiply by 2. Then get ABCD out. So you see, it is n square. This operation, because of nested parentheses, this operation will be O of n square. Thus, complexity will be O of n square. Cool. Again, n log n is the last operation, but the stack operation for you was actually resulting in O of n square. Cool. Let's see actually the code. Again, the code is very simple and exactly replicates of what I showed you as a dry run also. So what happens in the very beginning is I maintained a stack. That stack is a pair of string, which is the element, and the corresponding digit for it. This can be any digit. It can be 24. Again, this element, when I say element, it is MGSU, like this, okay, which means one capital, one uppercase letter and the corresponding lowercase letters, and then any number of digits. what will happen in the very beginning? You will get the character. Now, okay, obviously, I will break down as what I tried on also. I will break it down by saying I will get a capital letter, which is uppercase letter, following which I will have some number of lowercase letters, following which I will have some number of digits. This is lowercase letters. I'll do the same thing. I will get the element again. If this is the uppercase, I will get that specific. I'm now building that element. I'm now building that OZY. So I got my O here. Then I will iterate on up till I have lowercase letters. So I'll iterate on up till I have lowercase letters. So okay, next is Z, next is Y. Cool. So I've iterated up till I have lowercase letters only. Then when this is out, I will iterate after that lowercase letters what all digits I have and put them as strings. So I'll iterate, and let's say if I have 3, 2, so I'll iterate and put all those digits as my string. Now I have achieved my string. There could be a possibility that I have no digits at all after anything, because after MGIC I have no digits. So in that scenario, your digit string will be empty. In that scenario, put that as 1. Empty means 1. Now I will convert this string to my actual integer, because this will help me in multiplying faster and easier. And I know everything after multiplication will lie inside integer limit, so I don't have to worry about overflow. Now, when this portion is done, what has happened so far is you got your uppercase letter, you got your all lowercase letters, you got all your digits. Make sure to put them in your stack, because your stack needs element, which is uppercase and lowercase, and the corresponding digits. So I will put this in my stack, which means the element and the corresponding digits. Now, make sure, don't get baffled by these two for loops. What happened in this, I iterated on a specific uppercase character, then I went on to all the lowercase characters, then all the digits. Now my pointer is pointing here. So as you can see, now my pointer is pointing to k minus 1 again, because of this k increased. So you technically was doing your k was here itself. So I put my k as I minus 1, because I know next time my for loop will indirectly increase my I by 1. So I did a k minus 1 here. Okay, this was a case when you had this capital character, or basically uppercase. What else is remaining? What else is remaining is, what if you had a opening bracket? Okay, if opening bracket, simply push that opening bracket into your stack. Okay, done. Then what else can be there? Okay, what if I have a closing bracket? I told you, in a scenario of closing bracket, make sure to iterate on all the digits after that closing bracket, and let's say for example in this case, iterate on all the digits after that closing bracket. Make sure to multiply that digit number inside everything until you receive a opening bracket. So now if it's a closing bracket, I will firstly iterate on all the digits after that closing bracket. So I made a digit array in which I will iterate on all the digits after, again, all digits only after my closing bracket. Now again, if it is empty, you will by default have a 1, as in this scenario, if you remembered, as in where it is gone, yeah, as in this scenario, if it is empty, it's a 1. Now you have got a multiplication factor. You will simply start popping out from your stack, multiply with this specific digit and put it back into your stack after you have received an opening bracket. So I have put a temporary vector, as I showed you while I was try running this portion, that I will put them out in a temporary vector, and then when this is done, I have received the opening vector, I will push them back. Cool. So did the same thing here itself. I got them out in a temporary vector. I told this is the opening pair I'm looking for. Until you have received this opening pair, keep on popping from the stack, multiply with the specific digit which is after that closing bracket, and then this stack.pop is just popping out this specific opening bracket. Cool. When this is done, your stack actually has multiplication, like with the specific multiplied factor. Now when this portion is done, you know that you have to simply remove from the vector which you have put all the multiplied variable, put it back to your stack, because it can be a nested stack, nested thing. So you want to put it back to your stack, because your stack should contain everything. And ultimately here also, because you did jump on to all the digits, make sure to not repeat the loop and you are at a specific character, which means here the j will actually point after iterating this, your j will point here. So your I should point to j minus 1 because next time you will actually be you'll actually be increasing your I, obviously. Now when this portion is done, your stack contains the actual correct value, but you have to put them as sorted with the proper indexes, proper frequency. So I will empty my stack. I will make sure I'm using a map, because this map, the complexity will be nlogn. So I used it, and then after using it, I just keep on adding the frequency in the existing element count, and then ultimately I will iterate on this map and represent them as element and the corresponding digit. Again, to improvise this portion of complexity, because this is also again taking O of n square time, if you know, because I am adding string. So string plus is equals to string plus string. It takes that, okay, if the string is of size n, you're basically adding n as a string. So what will happen is every character will be added. So this is not a good operation. How you can optimize this is iterate on this element and say for character, let's say for like this, for auto C in your element, answer plus is equals to C. For auto C in your digit, answer plus is equals to C. This is the optimized version to write the same thing, but it is short, so I've written like this. But in an interview, make sure to write like this. This is not a good technique to add strings in C++. Cool. You can add a character. It is a O of 1 operation, but this is a O of n operation. Now, coming on back, again, make sure to write like this. Now coming on back, I'm just iterating on the map, and then if the string digit is 1, make sure to put it as empty, because for 1, it represents an emptiness. And now this is your answer. You know that the time will be O of n square because of, again, this is O of n square plus O of n log n, and this O of n square is because of stack. This is n log n because of the problem requirement. Problem wanted us to sort the actual keys or elements. Space will be just nothing but O of n itself, because you are using only stack. Now, can you improvise it is a question. And obviously you can think of it, and the answer is yes. Now, how you can think of it is by simply saying that, if you remember, the issue, the n square portion came in just because of nested loops, which means this 2 should come here and should come here. I remove it, I put it back to stack. Then this 2 will come here also, and here also, and here also. So because of all of this stuff, basically you were using your O of n square time. How we can improvise it? By simply saying, if ultimately I know that this 2 should be consumed here, this 2 should be consumed here, then this is gone. This 2 should be consumed here, 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 then this 2 is gone. So isn't it like if you can indirectly know where this 2 should be multiplied, then you could just multiply it while making your string, just multiply it with that 2. While making your O, you were saying O and lowercase were 0, like no lowercase, and then the frequency was 1. Simply say multiply by 2. Okay, Aryan, that seems good. That here I have O, and then I can make lowercase, which is zy. Then if I have a frequency of 3, I will multiply by 4, means into 4. But how will I achieve this? That's a question. That's a question. Now, in this scenario, just, okay, try to build it. Okay, how I will try to build it? I will go on from left. Okay, this. But if I go on from left, how will I know what thing I have to multiply? Because here it needs to multiply by 2. Here also 2. Here it was 4. Here it was 4. Let's change it. Let's say it is 3. So here it was 6 and here it was 6. So the question was, how will you even figure out that by what thing I should multiply these things? So let's make some pre-processing layer. Again, this pre-processing concept is very famous both in industries and also in your competitive programming. And usually you have heard this pre-processing thing in your prefix sum technique. But here also I can just do a suffix multiplication, which is same way saying that this 3 needs to be multiplied until I received another opening bracket. This 2 should be multiplied until I received corresponding opening bracket. So I know that this 2, I will keep on multiplying. This 2 should keep on multiplying until it receives its corresponding opening bracket. Now, whenever you want to know the correspondingness of a closing or opening bracket, you use a simple stack. So I will use a simple stack and will say that I will keep on multiplying my 2 until I receive the corresponding opening bracket. So I'll keep on multiplying by 2. Again, I will firstly go on to a specific closing bracket. I will get all the digits out of after that closing bracket. Then I will say, I will push that to my stack. Let's name it as a temporary stack. And then I will say, I will keep on multiplying with this value, with this multiplication factor. Or I can say multiply. I'll keep on multiplying, let's say MUL. I'll keep on multiplying by 2 until I receive a opening bracket. Now, how I will do it? I'll simply start and okay, I received the closing bracket. I had went on to all the digits. I received a 2. Then I will move on further. Oh, I received a 3. But okay, I will ignore it. I will go on to closing bracket. Again, this is right now I am building a pre-processing layer. How many times I should multiply any specific character, and I should build this specific type of an array. Here should be 1. Like this array I want to build. So I'm just focused only on the closing bracket right now. After the closing bracket, I went on to all the digits. But Aryan, isn't it a repeated process? No. What happened is I went on from the back. As I went on from the back, one time I will land onto any specific closing bracket. Then I will again go on forward in the back direction. I'll again go on forward and will check all the digits. So it is in the worst case iterating on that string 2 times. That's it. Then I will again move on back. Here I will again go on to all the digits, get out the digits, and then say that this is the digit. I should keep on multiplying. But earlier only I received a 2 multiplication factor. Now it is 6 multiplication factor which I should be multiplying. And I will say this is the 3 which I should keep on multiplying with. Then okay, I will again, when I say 6, I will keep on writing. Okay, I will just keep on writing 6, 6, 6, 6, 6, 6, 6. Now again, here at this point it was 2 and it was actually a 6. It was a 2. So I'm just writing that multiplication factor, because ultimately I know that when I will evaluate my answer, I will evaluate starting with the uppercase. So I would know that I have to multiply by 6, obviously. So although I am writing it everywhere, but I will use only at the uppercase location. Cool. Now, when opening bracket came in, I realized that I should be popping out from the stack, because now this is done, which means I should divide my 6 by 3. It will become a 2. So now it has become a 2. Again, keep on repeating 2, 2, 2. Again, opening bracket. Oh, pop it out. It became a 1, 1, 1. So this is the extra multiplication factor which I have built by using my pre-processing layer. Now, when this portion is done, you are good to do the exact same stuff as you did previously. Iterate on your specific thing. Again, now ignore these, ignore these, ignore these, ignore these, because they have no significance now. They have no significance now. Simply ignore these. Else, write the exact same code. Cool. Let's see the code. Again, exact same code I will show you. It's just that there will be a pre-processing layer at the top. What the pre-processing layer will say? Pre-processing layer will say, take a stack. Again, I have taken the stack which is not required anymore, but still, I have just copied the same code. That's the reason you will see the same duplicate thing. Now I have taken a temporary stack, which is this specific stack which I showed you, which will store for a specific closing bracket what all digits were posted or the number posted. So this is a temporary stack for that. Multiplication factor, which is in the very beginning as 1, and it will be multiplied by your number and will also keep on dividing by as you receive a opening bracket. Okay, and then this multiplication factor is actually the array itself, which I have built, this array. Then I will iterate on from the back. I will check if I have received a closing bracket, then iterate forward again, get all the digits out, convert that digit to actual integer, and then multiply your multiplication factor and then push that thing into your stack. This is when you receive a closing bracket. Again, don't go into that, Aryan, this is one for loop is here, one for loop is here, so it is O of n square. No. For one closing bracket, you are just iterating on all the digits again. So it is in worst case, again, this is only and only digits, only and only digits. If it's not a digit, it will break. So this in worst case will take O of 2n time, right? In worst case, iterating on every digit exactly twice. Now, if it is a closing bracket, that's good. Multiply the multiplication factor. But if it is not a closing bracket, if it's an opening bracket, then simply pop out from the stack, divide your multiplication factor by the specific digit, and then ultimately make sure to populate your array, which is the multiplication factor array, which is this array. I'll populate it. Now this is the logic of a pre-processing layer which I have built. This only logic. Rest all code remains same. What was the rest all code? Rest all code simply said if it's a uppercase, simply do the same stuff, go on to that again. The only added extra thing is I got my map in the top. You will know why, but the only factor is I just got one extra factor at this specific uppercase character. What is the multiplication factor? This will tell me that after getting the lowercase letters, after getting the digits, I should multiply with this multiplication factor. This existing digit, I should multiply with the multiplication factor. That's it. That's the only change. And then repeat the same process. Now, as you can see, I'm directly putting in my map. It is the reason I put the map at the top, because now no stack is needed here. But you remembered in your earlier case, you had your closing and opening brackets also. So simply continue, because now they will not be impacted. They will not impact anything. Ultimately, simply exact same code again, iterate on the map and get your answer. And by this, your time will be O of n, because of your entire stuff which you did here, because of this pre-processing layer, and then iterated on your entire stuff again. So it will be O of n plus n. But because of you wanted to get the answer in the sorted order, you have used a map. Only because of that, your complexity will be O of n log n. Space is again O of n itself. Cool. I hope you guys got it. I hope you guys got what's the use of pre-processing part. And if yes, then do smash like, baby. See you. Goodbye. Take care. I know a video a bit late, but I hope you guys got it. Bye bye.